Welcome to this presentation on containerization and orchestration with Docker and Kubernetes, a critical aspect of advanced system design. In today's session, we will dive into the concepts, tools, and best practices for containerizing applications and orchestrating them with Kubernetes. Let's get started. Here's an overview of today's presentation. We will first explore the concept of containerization, followed by a detailed introduction to Docker. Then we will dive into Kubernetes, a powerful orchestration tool for managing containers. Finally, we will wrap up by discussing best practices for both Docker and Kubernetes. At the end, we will summarize the key takeaways. Let's begin with containerization. Containerization is a technology that allows you to package applications and their dependencies into a portable, isolated environment known as a container. Containers run on the host operating system, sharing the OS kernel but maintaining isolation for applications, which makes them lightweight and efficient. The benefits of containerization include portability across different environments, resource efficiency, scalability, and isolation, making it ideal for modern distributed applications. Docker is one of the most popular containerization platforms. It simplifies the process of creating, deploying, and managing containers. A Docker image is a snapshot of an application and its environment, which can be used to create Docker containers. Docker images are built using a Docker file which contains all the instructions for creating the image. Docker Hub is a repository where developers can share and pull Docker images for various applications. Here are some essential Docker commands. Docker build is used to create an image from a Docker file. Docker run starts a container from an image. Docker ps lists all running containers. Docker stop is used to stop a running container. Docker pull allows you to download images from a repository. These commands are fundamental for working with Docker in any development environment. Here is an example of a simple Docker file. We start with a base image, in this case the official Node.js image. Then we set the working directory, copy the application dependencies, and install them using npm. After that, we copy the rest of the application and expose port 3000 where the app will run. Finally, we specify the command to start the app using npm start. This is a basic example, but Docker files can get more complex depending on the application's requirement. Kubernetes is an open source platform designed for automating the deployment, scaling, and management of containerized applications. It manages a cluster of machines and runs containerized applications on them. Kubernetes is highly extensible and can support any kind of containerized application, making it the industry standard for container orchestration. Kubernetes follows a master-slave architecture with a master node controlling the cluster and multiple worker nodes running the containers. The master node contains essential components such as the API server, the scheduler, and the controller manager. Worker nodes run the kubelet and kubeproxy components that ensure containers are running and manage the networking between them. Here are a few important Kubernetes commands. kubectl get pods lists all the running pods in the cluster. kubectl create -f Deployment.yaml creates Kubernetes resources like pods or services from a YAML file. kubectl scale deployment allows you to scale your application by adjusting the number of replicas. kubectl expose makes a pod available as a service so that it can be accessed externally. Here's an example of Kubernetes deployment YAML file. This YAML file defines a deployment for an app named MyApp, which runs 3 replicas of a containerized application. The deployment includes a container specification with a name and image and exposes port 8080 for communication. YAML is commonly used in Kubernetes for defining resources like pods, services, and deployments. Kubernetes provides powerful features for container orchestration, including scaling. It automatically adjusts the number of container replicas based on demands. Rolling updates. Kubernetes facilitates smooth updates by rolling out new versions of applications gradually. Self-healing. If a container fails, Kubernetes automatically restarts or replicates it to maintain the desired state. Service discovery and load balancing. Kubernetes help route traffic to the right containers, providing efficient communication and load balancing. Now let's look at some best practices for containerization. Keep containers lightweight, avoid unnecessary dependencies, making your containers smaller and faster to deploy. Use multi-stage builds. Separate the build and runtime environments to reduce image size. Organize with namespaces and labels. Simplify resource management in large-scale systems by categorizing containers efficiently. Automate with CI/CD. Implement continuous integration and continuous deployment pipelines to streamline the deployment process. To summarize, Docker and Kubernetes are powerful tools for managing modern distributed applications. Docker provides an easy way to create and manage containers, while Kubernetes helps orchestrate those containers at scale. By following best practices for containerization and orchestration, you can create efficient, scalable, and resilient applications. With these tools, your infrastructure will be well equipped to handle the demands of modern software development. That concludes our presentation on containerization and orchestration with Docker and Kubernetes. I hope you found the information helpful. Now let's open the floor for any questions. Feel free to ask anything about containerization, Docker, Kubernetes, or best practices.